Want to do some more homework problems. And this particular problem is kind of interesting. The number of common tangents that can be drawn to two externally tangent circles. By common tangent, we mean a line which is tangent to both circles at the same time. So here I've drawn two circles, different radii, and the circles touch each other at one point right here. So already we can see that there's one common tangent. This line right in here is tangent to both circles. But we can also draw two more lines that are tangent. Let's look at this right here. You see that we can draw this line right here, which touches this circles, touches the large circle here, touches the small circle here. Now remember, by its nature, the tangent it will be perpendicular to the radius of the circle drawn at the point of tangency. So this line is going to be perpendicular to the two radii of these circles. So now because it's going to be perpendicular, I hope that you can see, for example, imagine that this angle here is locked to be 90 degrees. In other words, the tangent line is always going to be perpendicular to the radius of the circle. So, for example, if we were to spin this radius around this way, the tangent line would spin around with it, so it would point up in this direction, for instance. So there's only going to be one such tangent to both circles on one side and one such tangent on the other side. So we have three common tangents to two circles which are externally tangent. So the answer to this question is 3. Now, let's look at another problem right in here. Is that if we're given two circles with two secants as shown, find the value of the arc designated by x. Now, so what do we have here? We're given that this large arc is 185 degrees. Well, what does that mean when we say an arc is 185 degrees? We mean the central angle subtended by the arc. So this angle here is 185 degrees. Now here we're saying this angle is 80 degrees. So this angle is this angle right in here, okay? And x is the length of this arc. So this arc going right across here subtends an angle, a central angle of x degrees. And the question is to find x. Now, if you recall earlier, we did a problem where we had two chords, or two secants intersecting a circle. Each secant intersected the circle at 2 points. And we came up with a formula for measuring the angle at which the two secants intersect. And that formula said that we look at the angle subtended by this arc and the angle subtended by this arc. We can, in fact, compute this angle. And the following formula is that formula. We said that 185 divided by 2 minus x divided by 2. So this arc measure divided by 2 minus this arc measure divided by 2 equals this angle measure, 80 degrees. So we solve for x here. Okay, multiply both sides of the equation by 2. We get 185 minus x is equal to 2 times 180, 2 times 80, which is 160. Okay, we bring x over to this side of the equation. So in other words, we add x to both sides. So then we subtract 160 from both sides, and we find that 25 is equal to x. Okay, so it says that the angle subtended by this arc here is 25 degrees. So that's the answer to that question. Let's do another problem. Okay, here's this problem right in here. Okay, now here again we have a circle, and the circle has this center right in here, and we want to find the measure of the angle designated by x right in here. Now we've drawn this. We've said that this arc subtends a central angle of 70 degrees. In other words, we're saying that this angle right in here is 70 degrees. Okay, now this is a radius of the circle, and this is a radius of the circle. So these two lines are equal. Okay, so this is an isosceles triangle. It says this angle must also be x. So we sum the angles in the triangle, and we get the 2x plus 70 is equal to 180. Or 2x is equal to 110. Or x is equal to 55. So the answer is angle x is 55 degrees. Okay, let's look at another problem. This problem right in here. Okay, we have a circle with two tangents. So here's one tangent, and here's the other tangent. And the angle between the two tangents is x. And both tangents come here from a common external point. That's this point right here. We want to find the angle measure of angle x. Now we also have the measure of this arc right in here. This is a big one. Is 260 degrees. Now we know that the total measure around a circle is 360 degrees. So that means that the measure of this arc right in here that goes from here down to here, that must be 100 degrees. So this arc is a measure 100 degrees because 100 plus 260 is 360. So that arc is 100 degrees. Now we know that this angle, and we know this from that, it's the problem that we just looked at, told us that if we had a secant, if we had two secants, but the secant intersects the circle at 2 points, the tangent only touches the circle at 1 point. So what I want to do is I want to draw two straight lines to help me with this. And so as we have to do in many geometry problems, so I draw this line, and I draw this line right in here. Now they're both radii, and then I'm going to draw this line right here. Okay. So what we have is that because this is a tangent and this is a radius, we know that this angle right in here is 90 degrees. Right? And we know that this angle right in here is 90 degrees. And this line right here is common to both triangles. So we have two right triangles, and the right triangles have two line segments in common. So we have this line segment is congruent to this one. This one is common to both triangles. And if you recall that with a right triangle, if we know we have a right triangle, we only need two congruent sides to make the triangles congruent, because with a right triangle, if we know any two sides, we can always compute the third side through the Pythagorean theorem. In this case, the third side we would compute by taking the diagonal squared minus the length of this side squared, and that will give us the length of this tangent squared. So if we know two sides of a right triangle, we can always figure out the third side, and we can use side, side, side then to say that these two triangles are congruent triangles. So the triangles are congruent. And we have this central angle here is 100 degrees. Now, if these triangles are congruent, then that tells us that this angle is equal to this angle right here. So those two angles, if this angle is 100 degrees, each of these angles must be 50 degrees. So each of those angles is 50 degrees. Here's right triangle, 90, 50. This angle here must be 40 degrees. Okay, this must be 40. And this angle right in here must be 40. Because 40 plus 90 must be 180. So these two angles are 40. This means that our whole angle x, which is the sum of these two angles, angle x must equal 80 degrees. So that's how we compute angle x. Okay, and I'll do one more here. Here is this problem. We're given that AC, that's this line segment right here, is equal to AB right here. So this is given AB is equal to AB in the AB is equal to AC in the circle. Which method for proving congruent triangles can be used to prove the triangle ACO is congruent to triangle ABO? Okay, well, let's see. They give us in the problem that this line is equal to this line, so we have that. This line is common to both triangles, and this line is a radius, as is this line. So these two lines must be equal. So we have two triangles, and the two triangles have each have three congruent sides. That to that, that to that, and this to itself. So the way to prove the two triangles are congruent is by using side, side, side. So that was pretty straightforward. Okay, do some more problems next time.